Hi everyone, this is the final video for the solutions to the 2025 Extension 2 Maths HSC paper. In this video we're going to look at questions 14 to 16. 14a. Let in equal the integral between pi on 4 and pi on 2 of cot theta to the power of 2n d theta for integers n greater than or equal to 0. Part 1, show that in is equal to 1 over 2n minus 1, take away in minus 1 for n greater than 0, given that d theta of cot theta is equal to negative cosec theta all squared. So I always like to start with questions like this by writing out, in this case, what in minus 1 is, because that might give me a clue of what I want to do. So in minus 1 is the integral between pi on 4 and pi on 2 of cot to the power of 2 brackets n minus 1 theta d theta, and that of course is equal to 2n minus 2. So that gives me the idea that I might want to split this up. So in is equal to the integral between pi on 4 and pi on 2 of cot theta, cot squared theta, cot 2n minus 2 theta d theta. Now, often in these cases we are looking at integration by parts, but that's not particularly useful because neither of these things are easy to integrate. So instead, let's do a substitution of one of those identities. So we know that sine squared theta plus cos squared theta is equal to 1. I want the one with cot, and so that is cos over sine. So I want to divide everything by sine squared, which is 1 plus cot squared theta is equal to cosec squared theta, and that is making me feel comfortable. So equals integral between pi on 4 and pi on 2. Instead of cot squared we have cosec squared theta, take 1 times cot to the power of 2n minus 2 theta d theta. Expanding the brackets, we get the integral between pi on 4 and pi on 2 of cosec squared theta cot theta to the power of 2n minus 2 d theta, take away integral between pi on 4 and pi on 2 of cot 2n minus 2 theta d theta, and this of course is in minus 1. And now we're going to use what we were given, this part here. So we know that the derivative of cot theta is equal to negative cosec squared theta, so we can use a reverse chain rule on this here. This part here, we've got cot theta to the power of 2n minus 2. So this is going to be equal to, we're going to raise this power by 1, so cot theta to the power of 2n minus 1 divided by the new power, divided by the derivative of the inside function, which is negative cosec squared. And that's going to cancel out with this, except for the negatives, so we need another negative there. Pi on 4 up to pi on 2, take away in minus 1, which is equal to, let's take that 1 on 2n minus 1 out the front, and we're going to substitute the pi on 2 in for theta and then subtract what we get when we substitute in pi on 4. So it's cot pi on 2 to the power of 2n minus 1, take away cot pi on 4 to the power of 2n minus 1, take away in minus 1 equals negative 1 on 2n minus 1. Now, cot is 1 on tan, and 1 on tan pi on 2 is 0. Take away cot pi on 4 is 1 on tan pi on 4, that's 1 on 1, so that's 1, 1 to the power of 2, n minus 1 is still 1. Take away in minus 1 is equal to 1 on 2n minus 1, take away n minus 1 as required. Part 2, hence or otherwise, calculate I2. So I2 is equal to 1 over 3, take away I1, which is equal to 1/3, take away, and I1 is 1 over 1, take away I0, which is equal to 1/3, take 1, plus I0 is pi on 4, integral between pi on 4 up to pi on 2, of cot to the power of 0 theta d theta. Let's come up here because we're nearly finished. A third take away 1 is negative 2/3, plus we've got the integral of theta, integral of 1 d theta, so that's going to be theta, in between pi on 4 and pi on 2, which is equal to negative 2/3 plus pi on 2, take pi on 4, which is equal to pi on 4, take 2/3. 14b, the acceleration of a particle is given by this. X is the displacement of the particle from a fixed point O after t seconds in meters. Initially the particle is at O and has a velocity of 12 meters per second in the negative direction. Show the velocity of the particle is given by this. All right, so we know one of the different versions of acceleration we can write is d dx of a half v squared, and that is equal to 32 x squared plus 3. And integrating both sides, a half v squared is equal to 32, the integral of x cubed plus 3x dx, which is equal to 32 x to the power of 4 on 4 plus 3x squared on 2 plus c. Resolving the constant at t is equal to 0, x is equal to 0, and v is equal to negative 12. So this is a half times negative 12 squared is 144, which is equal to 32, 0 plus c. Therefore, c is equal to 72. So we have a half v squared is equal to 32, and then in brackets, x to the power of 4 over 4 plus 3x squared over 2 plus 72. Multiplying everything by 2, v squared is equal to 64, x to the power of 4 on 4 plus 3x squared on 2 plus 144, and expanding through we get 16 x to the power of 4 plus 32 times 3, 96 x squared plus 144. Can we factorize that 16 out? I don't know. 96 divides 16, 6. 144 divided 16, 9. Oh, you beauty, look at that. Equals 16 x squared plus 3 all squared. All right, we've got to find v, not v squared. And so v must be equal to plus or minus 4 x squared plus 3. But it can't be equal to both positive and negative, so we need to figure out which one it is. We know that when t is equal to 0 and x is equal to 0, v is negative. And so we want the negative version of this. Therefore, v is equal to negative 4 x squared plus 3. Part 2, find the time taken for the particle to travel 3 meters from the origin. So we have this, and we want to introduce time, so we want dx dt is equal to negative 4 x squared plus 3. Let's take reciprocals of both sides, which I just didn't do. Dt dx is equal to negative 1 over 4 x squared plus 3, and so t is equal to negative 1/4 integral of 1 over x squared plus 3 dx, which of course is inverse tan. And using our formula sheet, we want inverse tan of x over root 3, and then we're going to have 1 over root 3 at the front, plus c. And so all we've got to do now is resolve that constant. Now we want to resolve the constant, and we know when t is equal to 0, x is 0, and that's going to make c 0. So t will equal negative 1 on 4 root 3 inverse tan of x on root 3. All right, answer the question. Find the time taken for the particle to travel 3 meters from the origin. Now we know that it's initially going this way, so we want x is equal to negative 3. I reckon that's a mistake a lot of people made. Negative 1 on 4 root 3 inverse tan of negative 3 on root 3. Okay, 3 on root 3 is root 3. Okay, so this is equal to negative 1 on 4 root 3 inverse tan of negative root 3. Now obviously we can have time that's negative, so it'd be good if we had a negative answer here. So let's do that. We'll go into that fourth quadrant down here. So negative 1 on 4 root 3. Inverse tan of root 3 is pi on 3, so we want negative pi on 3. So our answer will be pi on 12 root 3 seconds. 14c, let w be a complex number such that 1 plus w squared plus dot 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 plus w to the power of 6 is equal to 0. Part 1, show that w is a 7th root of unity. So we know that w to the power of 6 plus w to the power of 5 plus w to the power of 4, etc. is equal to 0. I'm going to multiply both sides by w minus 1. And we know that this, if we expand it all out, we have w to the 7 minus 1 is equal to 0, and in other words, w to the power of 7 is equal to 1. Therefore, w is a 7th root of unity. Part 2, find the other root of x squared plus bx plus c equals 0 in terms of positive powers of w. So if we know one of the roots is this, we'll call beta the other root. And so we've got x take away w plus w squared plus w to the power of 4, and then x minus beta. Now we want the sum of the roots, which is w plus w squared plus w to the power of 4 plus beta, to be real. So we want to use this here. We also want the product of the roots to be real, so beta multiplied by w plus w squared plus w to the power of 4. So it seems to me that a good guess for beta would be w cubed plus w to the power of 5 plus w to the power of 6, because if we add this and this, we're going to get negative 1. But does it work for this? Well, the only way to find out really is to expand these. Which is equal to w to the power of 4 plus w to the power of 5 plus w to the power of 7 plus w to the power of 6, w to the 7, w9 plus w7, w8, w10, which of course is equal to w to the power of 4 plus w to the power of 5 plus 1 because w to the power of 7 is equal to 1, plus w to the power of 6 plus 1 plus w squared plus w, nope, not w, it's 1, this is where 2, here, plus w cubed, which equals, now we know this, so 1 plus w squared plus w cubed plus w to the power of 4, w to the power of 5, and w to the power of 6 is 0 plus 1 plus 1 is equal to 2, which is real. And so the other root is w cubed plus w to the power of 5 plus w to the power of 6. Part 3, find the numerical value of c. So we know the product of the roots is equal to c on a is equal to 1, therefore c is equal to the product of the roots, which is 2. 14d. Positive real numbers a, b, c, and d are chosen such that 1 on a, 1 on b, 1 on c, and 1 on d are consecutive terms in an arithmetic sequence with common difference k. K is a real number, k is greater than 0. Show that b plus c is less than a plus d. So we are required to prove that b plus c, take away a, take away d, is less than 0. All right. So let's start with b plus c, take a, take d. That is the same as negative brackets a minus b plus and brackets c minus d. Now, from this, we know that 1 on b, take away 1 on a, is equal to 1 on d, take away 1 on c. In other words, a minus b on ab is equal to c minus d on cd. In other words, cd, a minus b, is equal to ab, c minus d. Okay, can we do a substitution here? A minus b is equal to ab, c minus d all over cd. Okay, so this is equal to negative a, b, c minus d on cd plus c minus d, and making it into 1. We've got c, d. I'm going to bring that out the front. Actually bring the c minus d out the front, and we will get cd minus ab. All right, we want to see if this is less than 0. All right, we need to now prove that this is less than 0. Now, the other thing we know from here is that 1 on a must be less than 1 on b, which is less than 1 on c, which is less than 1 on d. And taking the reciprocals, it means that a is greater than b, is greater than c, is greater than d. So that means c take away d, c minus d is positive. We know cd is positive because they're all positive real numbers. So I'm hoping that cd take away ab is negative. Because of this, a is greater than b is greater than c is greater than d. AB must be greater than CD. Therefore, CD minus AB is less than 0. And so this whole thing is less than 0, and we've proven it. Question 15a. The adjacent sides of a parallelogram are represented by the vectors a and b. Show that the area of the parallelogram is 6 root 10 square units. Now this question really annoys me because if you use the cross product, you get there in a couple of lines. But the cross product's not actually taught in Extension 2. Now, if you did happen to know the cross product and you did it that way, I imagine you will get the marks, but there's no point doing that on this video. We need to use the maths that we've actually been taught. So let's have a look. Say this is vector A here and vector B here. Now, we're going to drop this perpendicular and call it X. And we know that the area of the parallelogram will be the magnitude of vector B times that height x. So how are we going to work out x? Well, we can work out this angle here because it is the acute angle between vectors A and B. So let's start with that. Cos theta is equal to A dot B over magnitude of A, magnitude of B. We've got an added complication here because we have got exact values, but never mind. Okay, the dot product of A and B is going to be 8, take away 3 over the square root of this magnitude here. So that's 16 and 1 and 9 is 26. And here, magnitude of this one is 4 plus 1 plus 9 is 14. And so that is 2 over the square root of, what's 26 times 14? 26 times 14, 364. Now I can reduce that down, and I think it's a good idea to do it. I can bring the 2 out. Root, so 364 divided by 4 is 91. Which will give us 1 on root 91. Okay, in order to work out x, we're going to use right-angled tricks. So sine theta is equal to x over the magnitude of vector A, which was root 26. And so x is going to be equal to root 26 times sine theta. Now we need to get an exact value for x, and so we need an exact value for sine theta. So let's draw up a right angled triangle where we've got theta here and we've got adjacent over hypotenuse, which using Pythagoras' theorem will give us root 90 there on the opposite side, and so sine theta is equal to root 90 over root 91. So x is equal to root 26 times root 90 over root 91, and so the area of the parallelogram will be magnitude of B, which is root 14, times root 26 times root 90 over root 91, which is 14 times 26 times 90 divided by 91 is 360. Square root, which is 6 root 10. Question 15b. A particle moves in simple harmonic motion about the origin with amplitude A. And it completes 2 cycles per second. Now that's the frequency. Now remember that period is the reciprocal of frequency. And we know period is equal to 2 pi on n. So therefore, n is equal to 4 pi. When it is 1/4 meters from the origin, its speed is half its maximum speed. Find the maximum positive acceleration of the particle during its motion. Alright, so we know that x double dot is equal to minus n squared x. So that's minus 16 pi squared x. Now I'm going to use this formula, v squared is equal to n squared a squared minus x squared, because we know the amplitude and we know n. So it's 16 pi squared, amplitude is capital A, take away x squared. Now we know that the maximum speed occurs at the center of the motion. So that's at x is equal to 0. So v squared max is equal to 16 pi squared a squared. And when x is equal to 1/4, the speed is half the maximum speed. So we don't want v squared, we want v. So that would be a square root, which is 4 pi a, and at x is equal to 1/4, the speed will be half of that, so 2 pi a. So substituting now into here, we will get v squared, so 4 pi squared a squared is equal to 16 pi squared a squared take x, I'll take a quarter squared, which is 1 on 16. So these pi squareds can go. 4a squared is equal to 16 a squared take 1. And so 12a squared is equal to 1. A squared is equal to 1 over 12. Amplitude is only ever positive, so it is 1 over 2 root 3. Right, find the maximum positive acceleration. So we know that maximum acceleration occurs when the particle's turning. So it's either going to be at 1 on 2 root 3 or at negative 1 on 2 root 3. So using this now, x dot dot will be equal to negative 16 pi squared. Because we want maximum positive acceleration, we're going to take this guy here, so negative 1 over 2 root 3, which will give us 8 pi squared on root 3 meters per second squared. 15c, part 1, show that 1 plus cos theta plus I sine theta over 1 minus cos theta minus I sine theta is equal to I cot theta on 2. So starting with the left-hand side, we're going to multiply top and bottom by 1 minus cos theta plus I sine theta, and that will realise the denominator. Now I like to group in pairs to help with this expanding, like this. Alright, so it equals, by multiplying that by that, I have the difference of 2 squared, so that's 1 minus cos squared theta plus I sine theta, 1 plus cos theta, plus I sine theta, 1 minus cos theta, plus I squared, so that's minus sine squared theta, all over. I've got this times this, so 1 minus cos theta all squared, and I have the difference of 2 squareds here, so minus I squared, so that's plus sine squared theta. All right, expanding and simplifying. This here is sine squared theta plus I sine theta plus I sine theta cos theta plus I sine theta minus I sine theta cos theta minus sine squared theta, all over 1 minus 2 cos theta plus cos squared theta plus sine squared theta, and sine squared take away sine squared is 0, and I sine theta cos theta take away I sine theta cos theta is also equal to 0. So on the numerator, I have got 2I sine theta over 1 plus 1, so 2 take 2 cos theta, which is equal to I sine theta on 1 minus cos theta. All right, we need to get these theta on 2's in, and the way to do that, of course, is double angle formulas. So sine 2 theta is equal to 2 sine theta cos theta. So this is equal to 2I sine theta on 2 cos theta on 2. And to get cot, I want sine on the bottom, so cos 2 theta, you know that there are a couple of different forms. So cos squared minus sine squared, let's get the sine version, 1 minus 2 sine squared theta. So on the denominator we'll have 1 take away 1 minus 2 sine squared theta on 2, which is equal to 2I sine theta on 2 cos theta on 2, all over 1 take 1 is 0, 2 sine squared theta on 2. The 2's cancel. This sine Theta on 2 cancels with one of those, and I'm left with I cos theta on 2 over sine theta on 2, running out of room, which is equal to I cot theta on 2, which is equal to the right-hand side. Part 2, used de Moivre's theorem to show that the sixth roots of -1 are given by this. So we're going to let z equal cis theta, and we know that z to the power of 6 will equal -1. So we can say that cis 6 theta is equal to cis pi. Therefore, 6 theta is equal to pi plus 2k pi, where k is equal to 0, 1, 2, 3, 4, or 5. And so theta will equal pi plus 2k pi all over 6. And we can tidy that up a bit, can't we? 2k plus 1 over 6 pi. So the roots are this 2k plus 1 all over 6 pi for k is equal to 0 to 5. Part 3, hence or otherwise, show the solutions to z minus 1 over z plus 1 all to the power of 6 equals -1 are these. Okay, so we know that if we're solving w to the power of 6 equals -1, we just worked out what the sixth roots of -1 were, and they were, let's put wk, cis 2k plus 1 over 6 pi. So that means that z minus 1 over z plus 1 is going to equal all of these roots. And k is equal to 0, 1, 2, 3, 4, and 5. Now, that means that z minus 1 is equal to z plus 1 times cis 2k plus 1 on 6 pi. Okay, so z minus 1 is equal to z cis 2k plus 1 on 6 pi plus cis 2k plus 1 on 6 pi. And so z, brackets 1 minus cis 2k plus 1 on 6 pi must equal cis 2k plus 1 on 6 pi plus 1. Therefore, z is equal to, I'm not sure if I can fit this in. Let's go over here. Z equals cis 2k plus 1 on 6 pi plus 1 all over 1 minus cis 2k plus 1 on 6 pi. Which from part 1 is equal to I cot theta is 2k plus 1 over 6 over 2 pi I cot 2k plus 1 on 12 pi for k is equal to 0, 1, 2, 3, 4, 5, which if you substitute them all in, you will get that. 16a, consider the equation given here. Z is a complex number, theta is real, n is a positive integer. Using a proof by contradiction and the triangle inequality, or otherwise prove that all the solutions to the equation lie outside the circle modulus of z is equal to 1/2 on the complex plane. Okay, so we're going to start by taking a contradiction to this part here. We're going to assume that there is one solution, let's call it W, that lies inside this circle or on the circle. So assume that there is one solution W such that magnitude of W is less than or equal to a half. Now, from here, we know that w to the power of n cos n theta plus w to the n minus 1 cos n minus 1 theta dot 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 plus w cos theta must equal 1, and we can take absolute values of both sides like this. And of course, absolute value of 1 is 1. So just turning that around, we get 1 is equal to the absolute value of that whole thing. And now let's use the triangle inequality. The absolute value of that whole expression, those additions must be less than or equal to the absolute value of w to the power of n cos n theta plus absolute value of w to the power of n minus 1 cos n minus 1 theta plus dot 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 plus the absolute value of w cos theta. Now let's just use some of our properties of absolute values. So this is equal to, we can split up products, absolute value of w to the power of n, absolute value of cos n theta, plus absolute value of w to the power of n minus 1, absolute value of cos n minus 1 theta, that's an absolute value, plus dot 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 plus absolute value of w, absolute value of cos theta. Now we know that all of these cos terms are less than or equal to 1. Therefore, this whole expression must be less than these absolute value of these w's. Absolute value of w to the power of n plus absolute value of w to the power of n minus 1 plus dot 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 plus absolute value of w. And using another property of absolute values, this is the same as absolute value of w to the power of n plus absolute value of w to the power of n minus 1 plus dot 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 plus absolute value of w. But we are assuming that the absolute value of w is less than or equal to a half. So this will be less than or equal to a half to the power of n plus a half to the power of n minus 1 plus dot 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 plus a half. I'm just going to turn that around. Find it easier to sum. Okay, which is equal to, using sum of a GP, so half, 1 take away, common ratio is a half to the power of n, 1 minus a half. That's a half divided by a half, so that equals 1 take away 1 on 2n. And this is an absurdity. 1 is never less than or equal to 1 minus 1 on 2 to the power of n. Therefore, a contradiction. Therefore, all solutions lie outside the circle z is equal to a half, absolute value of z is equal to a half. 16b, a particle of mass 1 kilogram is projected from the origin with a speed of 50 meters per second at an angle theta below the horizontal into a resistive medium. The position of the particle 2 seconds after projection is xy, and the velocity of the particle at that time is v. The resistive force R is proportional to the velocity of the particle, so that R is equal to negative kV and k is a positive constant. Taking the acceleration due to gravity to be 10 meters per second squared and the upwards vertical direction to be positive, the acceleration of the particle at time t is given by A. Derive the Cartesian equation of the motion of the particle given that sine theta is equal to 3/5. Okay, so I'm going to split this into two systems because notation is going to get the better of me. So I'm going to start with the horizontal system. A is equal to negative kV. I'm going to use dv dt, which is equal to negative kV, and therefore dt dv is equal to negative 1 on kV. So t is equal to negative 1 on k, integral of 1 on v dv, which is equal to negative 1 on k ln v plus c. Now vertically, we have got a is equal to negative kv minus 10. So dv dt is equal to negative kv minus 10. Flip it upside down, dt dv is equal to negative 1 over kv plus 10. T is equal to negative the integral of 1 over kv plus 10 dv, which is negative ln kv plus 10, divide by the derivative of the inside function, which is k plus c. Now we're going to need initial conditions. So we know when t is equal to 0, x is equal to 0, and we need the horizontal component of velocity, which would be 50 cos theta, and we need the vertical component of velocity, which is going to be 50 sine theta, and we can see also it is going to be negative. So that we're told that sine theta is equal to 3/5, so this will be negative 30, and horizontal component will be, we're going to need to do this, sine theta is equal to 3 over 5, so that's 4. So cos theta is equal to 4/5, so that is 40. Okay, so 0 is equal to negative 1 on k ln 40 plus c. C is equal to 1 on k ln 40, and so t is equal to negative 1 on k ln v over 40. Now vertically, 0 is equal to negative 1 on k ln, and we have got velocity equal to negative 30, so let's do 10 take away 30k plus c. Therefore, c is equal to 1 on k ln 10 minus 30k, and t will equal negative 1 on k ln kv plus 10 on 10 minus 30k. Okay, now let's work to making v the subject. So we've got negative kt is equal to ln v on 40. V on 40 is equal to e to the negative kt. V is equal to 40 e to the negative kt. And this is dx dt. And so x is equal to 40 integral e to the negative kt dt. And vertically, negative kt is equal to ln kv plus 10 on 10 take 30k. E to the negative k, kv plus 10 on 10 minus 30k. kv plus 10 is equal to 10 minus 30k e to the negative kt. kv is equal to, let's take this 10 out, 1 minus 3k e to the negative kt, take 10, and so v is equal to 1 or 10 on k, 1 minus 3k in brackets e to the negative kt, take 1. We have 40 e to the negative kt on negative k plus c. We know at t equals 0, x is equal to 0. So 0 is equal to negative 40 on k. That is 1 plus c. Therefore c is equal to 40 on k. And so x is equal to 40 on k, 1 take e to the negative kt. And over here dx dt is equal to 10 on k 1 minus 3k e to the negative kt, take 1. X is equal to 10 on k, integral 1 minus 3k e to the negative kt, take 1 dt equals 10 on k. Actually, that's not an x, that's a y. Integrating 1 minus 3k e to the negative kt on negative k, take away t, plus c. Again, at t is equal to 0, y is equal to 0. C is going to be equal to 10 on k squared, 1 minus 3k. Let's keep going with the vertical side, and we're going to need to tidy this up a little bit. We've got, oh yeah, I can see k there. 10 on k squared gives us, God, if I take the negative out, that might help me. 1 minus 3k e to the negative kt. I brought the negative out, but I need a k. I think I've got plus k t here. Let me just check that for a second. Yep, that's right. Plus 10 on k squared. Actually, let's not do that. Let's make it a little bit easier. We can join that together, because we've already got that, so we need minus 1 minus 3k equals negative 10 on k squared, 1 minus 3k e to the negative kt minus 1 plus kt. Alright, making t the subject over here, so we've got kx on 40 is equal to 1 minus e to the negative kt. E to the negative kt is equal to 1 minus kx on 40, which is equal to 40, take kx on 40. Negative kt is equal to ln 40, take kx on 40. And so t is equal to negative 1 on k ln 40 minus kx on 40. We are nearly there. Substituting in, we get negative 10 on k squared, 1 minus 3k e to the negative k times negative 1 on k ln 40 minus kx on 40 minus 1 plus k times negative 1 on k ln 40 minus kx on 40 equals negative 10 on k squared, 1 minus 3k. This cancels with that, and I've got e and ln which undo one another, so I end up with 40, take kx on 40, take 1. That cancels, minus ln 40 minus kx on 40. Which is equal to negative 10 on k squared, 1 minus 3k, 40 minus kx minus 40 on 40, minus ln 40 minus kx on 40, which is equal to negative 10 on k squared, 1 minus 3k, cancels, negative k, so that's times, negative kx on 40 minus ln 40 minus kx on 40. Let's just take that negative out. It equals 10 on k squared. Kx on 40, 1 minus 3k plus ln 40 minus kx on 40. 16c. Consider the point B with three-dimensional position vector B and the line L, A plus lambda D, where A and D are three-dimensional vectors. Modulus of D is 1 and lambda is a parameter. Let f of lambda be the distance between a point on the line L and the point B. Part 1. find lambda 0, the value of lambda that minimizes f in terms of A, B, and D. So let's start by drawing a diagram. We've got line L, we've got point B, which has position vector B, and we need a generic point on the line, let's call it A, and it's going to have coordinates A plus lambda D. Now, f of lambda will be equal to the length of the vector AB, which is the length of vector B take away A take away lambda D. Now, really difficult to do this without going into components because we want to use calculus, so let's just do that. It's the square root of B1 minus A1 minus lambda D1 all squared plus B2 minus A2 minus lambda D2 all squared plus B3 minus A3 minus lambda D3 all squared. Differentiating, we get f dashed of lambda is equal to a half times B1 minus A1 minus lambda D1 all squared plus B2 take A2 take lambda D2 all squared plus B3 take A3 take lambda D3 all squared to the power of negative a half times by the derivative of this inside function, which is 2 times B1 take A1 take lambda D1 times by D1 plus 2 times B2 take A2 take lambda D2 times D2 plus B3 take A3 take lambda D3 times D3. And we want to know when this is equal to 0. Now this part here is on the denominator, so it doesn't matter. So it essentially comes down to solving a half times 2 B1 take A1 take lambda D1 and 2 B2 take A2 take lambda D2 plus, I lost a 2 there, did you see that? 2 B3 take A3 take lambda D3 is equal to 0. And these 2's will all cancel out with that half. Okay, expanding, we've got B1 take A1 times D1, take away lambda D1 squared plus B2 take A2 times D2, take lambda D2 squared plus B3 take A3 times D3 take lambda D3 squared is equal to 0. And we know this and this is the dot product, B take A dot D take away lambda, and D1 squared plus D2 squared plus D3 squared is the magnitude of D squared, which is equal to 0, but magnitude of D is equal to 1. Therefore, lambda is equal to B take A dot D. We're wanting to find lambda naught, which is the value of lambda that minimizes f in terms of A, B, and D, and there it is. Part 2, let P be the point with position vector A plus lambda naught D and show that PB is perpendicular to the direction of the line L. So here is P, here, and it has vector A plus lambda naught D. So we want to prove that BP dot the direction vector of line L would equal 0. And so BP is equal to A plus lambda naught D take away B, which is equal to A plus, subbing this in, D dot B minus A multiplied by D take away B. So BP dot D is equal to A plus D dot B minus A D minus B dot D. Okay, let's expand. A dot D plus D dot B minus A D squared, take B dot D. All right, we know that's equal to 1. We also know that B is perpendicular to D. So that's equal to 0. Expanding, A dot D plus D dot B, take away D dot A, is equal to 0 because D dot B is equal to 0. Therefore, PB is at right angles to or perpendicular to the direction of line L. Part 3. Hence or otherwise find the shortest distance between the line L and the sphere of radius 1 unit centered at the origin in terms of D and A. So there's our sphere, there's point B and point P. This is line L. You may assume that if B is the point on the sphere closest to L, then OBP is a straight line. Okay, so OP is the position vector of P. So that's A plus lambda naught D. And we know lambda naught is D dot B minus A. And that's equal to A plus D dot B minus D dot A times D. But we know that D dot B is equal to 0 because this is a right angle. Therefore, OP is equal to A minus D dot A times D. Now we need to work out the length of OP. I'm going to do OP squared is equal to, and I'm going to go into component form, partially into component form. A1 take away, I'm just going to leave this dot product alone, D1 all squared, plus A2 take that dot product, D2 all squared, plus A3 take D dot A D3 all squared. And expanding, A1 squared take 2A1 D1 dot product, plus D dot A squared D1 squared, plus A2 squared take 2A2 D2 D dot A, plus D dot A squared D2 squared plus A3 squared minus 2A3 D3 D dot A plus D dot A squared D3 squared. So I have A1 squared plus A2 squared plus A3 squared, which is the magnitude of A all squared. So that's all of those accounted for. Now these here, I've got minus 2 lots of this dot product, D dot A, and then I've got A1 D1 plus A2 D2 plus A3 D3, which of course is the dot product A dot D. So they're all done, and then it leaves me with these guys, which is plus D dot A all squared multiplied by D1 squared plus D2 squared plus D3 squared, which is magnitude of D all squared, which is equal to 1, equals magnitude of A all squared, take away 2 lots of D dot A all squared plus D dot A all squared is equal to magnitude of A all squared, take away magnitude of D dot A all squared. The length of vector OP is equal to the square root of all of this. Therefore, BP, the length, must be equal to OP, magnitude of OP, take away 1 because OB has length 1. So it is equal to the square root of absolute value of A squared take away absolute value of the dot product D dot A all squared take away 1. The end.